In this paper, we introduce a 5-step process to improve the management of memory in language learning models, LLMs, using MemGPT. The first step involves defining the main and external context. The main context refers to the LLM inputs that are bound by the maximum number of input tokens, while the external context refers to information held outside of the LLM's fixed context window. The second step divides the main context into 3 components: system instructions, conversational context, and working context. System instructions provide information about MemGPT functions and control flow, while the conversational context holds a FIFO queue of recent event history. The working context serves as a working memory scratchpad for the agent. The third step implements the external context as out-of-context storage. This can take various forms, such as databases for storing text documents and embeddings, vectors. MemGPT provides function calls for the LLM processor to query and bring information from the external context into the main context. The fourth step enables self-directed editing and retrieval of memory. MemGPT autonomously updates and searches through its own memory based on the current context. Explicit instructions within the pre-prompt guide the system on how to interact with its memory systems. Memory edits and retrieval are performed through function calls generated by the LLM processor. The fifth step implements control flow and function chaining. Events trigger LLM inference, and MemGPT processes events with a parser to convert them into plain text messages. Function chaining allows MemGPT to execute multiple function calls sequentially. Control flow can be returned to the user immediately after a function call or paused until the next external event trigger. We have made several improvements and modifications to MemGPT. The multi-level memory architecture provides a clear delineation between main context and external context. MemGPT enables LLMs to access out-of-context information through function calls, improving their ability to handle complex tasks. Self-directed editing and retrieval allow the system to autonomously update and search through its memory, improving its understanding and performance. The control flow and function chaining mechanisms enhance the flexibility and efficiency of LLM processing. MemGPT prompts the processor with warnings regarding token limitations, improving its awareness of context limits and guiding memory management decisions. Finally, MemGPT's memory retrieval mechanisms implement pagination to prevent retrieval calls from overflowing the context window, ensuring efficient memory access.